Very cool. So you've got the screen flash and you've got the five errors. Oh, good. Yeah.
I'm joking. Yeah, we're going to make a start. Yeah. Hello everyone. I think I know most of you anyway, but if anyone hasn't been here before, this is Liverpool LUG. My name is Dan. Tonight we're going to be talking about a project that's really only occurred in the last, 10 days maybe?
If that,
yeah. So I'm sure some of you know Alex went over there. This is a bit like Vic and Bob, isn't it? It's my assistant. And you know Matt as well. Matt's always at the lodge meeting now. So just give a bit of history. So what was it now? About 10 days ago, we were doing an event downstairs. We were helping to show a live stream of a thing called the Festival of Maintenance, which Jackie was at. And that was going on in London. And we were streaming from a camera down there, which Jackie had. There's talks to the event space downstairs. And we just got talking between us about ways of doing this and different solutions and stuff. And this whole kind of project has mushroomed out a bit, I suppose, or mushroom clouded out a bit, into a kind of open hardware, open software video streaming solution is what we're looking at. What ended up happening was we talked about various things which we'll get into, such as OBS. I don't know if anyone's seen that, Open Broadcast Studio. You kind of looking at the output from it, but we'll talk about that in a bit. Things like hosting our own RTMP video server, which we'll talk about in a bit, and forwarding that to a thing called Restream.io, which is a cloud service which will allow you to output it to about 30 different platforms at once. So it'll do all the usuals like YouTube, Facebook Live, Twitch, all those sorts of things. And the beauty of it was, what we wanted, I think anyway, I'm speaking for everyone here, but what the goal was to create a project where we could give people something simple like a box with a camera that they could very quickly configure simply to use, say, the Wi-Fi of the local venue, and then press a button effectively, or just start it streaming, and it to then be able to reproduce those streams to all those endpoints that I talked about. So that was the goal, and very quickly I was interested in using a Raspberry Pi for this, because it seemed like a good idea for the platform. You can get the Pi camera, you can plug in webcams, so you'll see them around the building, there's loads. So some of these you can see there's a bit of a delay on some of them, but there's like a Raspberry Pi there with a webcam on it, there's a Raspberry Pi behind Jackie there with a webcam stuck on top of the thing. There's various Raspberry Pi Zeros here, which Alex can talk about with little enclosures and Pi Zero cameras. And basically they all stream to, they're all streaming to our RTMP server, which is we'll get into, but it's basically a Debian virtual machine, which is running on a host under Matt's desk. Noisily under Matt's desk, and using a thing called Proxmox, which I've talked about before. It's just a KVM hosted thing, basically. I should say I'm going to use a lot of acronyms, so please don't worry about going, what are you talking about, what does that mean, what are you doing, because I haven't got slides planned or anything, as you can tell. So we've got a Debian Linux VM under the thing there with a custom version of Nginx, the lightweight web server, which I recompiled with an RTMP module, which we're documenting all this. That's the other thing, is we want this to be, what's the word, replicable, recreatable, redoable, restreamable. So we want other people to be able to recreate this with, commodity hardware, open hardware preferably, which is why we've got Pis and things like that. And the software is open as well, OBS. So that all streams to OBS actually, doesn't it? And then
so it streams to the RTMP server, and every single one of these cameras is an input into OBS. The RTMP server just sort of allows every device on the network to communicate and see what these cameras are open.
Yeah, so they're streaming over the Wi-Fi basically, all these little cameras around the back. There's one next door by the coffee machine, because you always need to know where your coffee is. So there's one there that Julian set up before, pointing at the coffee machine. But the idea is that people can just quickly get another camera set up with the software and stuff, and the hardware in the guide, and then add to it, and have their own hosted solution if they want, or they could use a central one, and stream events and things. So the point was, what we thought would be really good and a lot easier for Jackie would have been, rather than carrying a camera and backing it out, would be to have something like that, that you could have just put somewhere and then linked to local Wi-Fi at the venue.
Right, and then we could have took that footage and mixed it.
Yeah, and then, yeah. So, yeah, so obviously we haven't planned this out, but I think at this point it'd be a good idea for Alex to tell us a bit about how the software side works with Resin, I think called Resin.
Okay, try and do that, yeah. So, as Dan says, you've been in this for about 2 weeks now, not 10 days. We were spurred by the great work Jackie's been doing down in London, streaming to DoES. We've had a lot of conversations internally about all the great events that go on in this space and how we expose them to people around the wider community and indeed nationally and internationally. And everybody seems to be doing live streaming. You know, kids are streaming their games to Twitch, people are recording events and so on and so forth. So, you know, we should be able to go and take commodity hardware like Raspberry Pis and do something with it. So this project, MakeSpaceLive, is to explore how far we can go with a low-cost, really easy to set up solution so that anybody in any MakeSpace, any community, can get going streaming their event without trouble and difficulty. Now, you know, you might say, well, just a sec, I can do that on my phone, you know, why can't I stream off my phone? I think that's a fair point, but nobody really wants to leave their phone lying around at events doing things, and there's still setup with that to do. So the question for us was really, how could you grab a device like this little grey box that you see here, which is essentially a £10 Raspberry Pi Zero, which has got a camera attached to it. So the cameras are quite variable in pricing, but you know, the official ones are about 20 odd quid. We've sourced some which are on the way from China, which are about £6. So, you know, £10, £6 enclosure. That gives you a bit of an idea around the kind of price point that we're trying to look at to enable live streaming for people. And then the thing is that out there, there are lots of components which are great for live streaming. We've got YouTube Live, we've got Twitch for the gamers, we've got cloud streaming solutions, and we've got software that we can use on these embedded Linux platforms and Raspberry Pis. So really, it's not as though we have to invent anything new, it's just how do we wire it all up together and make it really easy for people who don't necessarily want to get into the ins and outs of the Linux command line and GStreamer pipelines so that it just works for them. That's what we're trying to achieve. Now this is, again, it's fairly early days. You can see the quality of this stuff is very variable. It's quite interesting to see how it's panning out here. I'm going to try and work out which of these cameras are which. So
I'm just going to point out the flickering on the coffee machine one is because there's a weird thing going on with the lights next door. So that's not actually, it's something happens with the camera, doesn't it, in there, and if you get one of those lights, they have some weird flicker thing that's not visible to the naked eye, but when you've got a camera on, you get that weird flickering. I'm pointing out just because to say it's not our camera.
It's interference with the mercury vapor discharge.
There's a good chance that it's because of the sampling rate of the camera not matching the figures.
Yeah, probably.
Yeah, because people wanted to take a picture of that persistence of vision thing on there.
Yeah, even if you just try and take a photo on your phone, you get that horrible.
On my phone, you can change the, the thing, and then you can see it properly. So maybe you can do that.
Maybe we can tune it, yeah.
But what's interesting is you're still getting it in here as well, though.
Yeah.
Yeah, we get it the same way.
That's in rate too, so it's different rate. Yeah.
Well, they say that you should either use 55 frame per second or 30 frame per second because it comes to exactly half of 50 or 60 hertz, which is
the lights,
yeah. So this
which country you're in.
is streaming at 30. So
yeah, but it depends on what truly the camera is capturing.
Yeah,
because there might be a convergence point, but there might not be something that's.
I mean, some of the things we need to look at are there are configuration options in here for trying to address sort of power line frequency problems that we've been looking at turning on and off. Hasn't helped a lot, to be honest, but it certainly needs looking at. So anyway, over in this corner here, we've got a Raspberry Pi Zero and a little vacuum enclosure. Same setup, iCam, Raspberry Pi Zero, and then we have one over here in the resin enclosure, which people at Sensor City very kindly had printed out for us earlier on today.
It's going to get confusing because you've got your resin software and your resin.
We've already confused you with that, haven't we?
Yeah.
And then we have two sort of slightly better quality webcams. And these are connected to Raspberry Pi 3s. So we've got our Logitech, is it a
C920.
C920 over here.
That's above where Jackie is on the top there with the blue lights on it.
Don't look right into it.
That's
Not silly now.
they're not cheap then, they're about 90 quid.
Comes in about £90 that.
Yeah, they're like top of the range. Yeah, full HD.
And this one is a lower end one, which is the C270, which comes in about £20.
Yeah, they're the like ones that we. So I've got that one because it's the standard one they recommend for video streaming for TV stuff.
It's interesting to see how much better that one looks, isn't it, than the others?
Yeah. Should have a low light performance. If you were all in high light performance, then it wouldn't be so bad for a majority. Although it'd be still obvious that that's better, it just wouldn't be as obvious.
So then, next thing is how do you get going with this? And if you're happy playing with Raspberry Pis, you can grab an image running, say, Raspbian or something like that. You can install the dependencies you need. And we're using a tool chain called GStreamer for these pipelines that we're running. I guess a lot of you know about that. For people who haven't looked at it, it's a nice sort of Swiss Army knife for audiovisual. You can take data from lots of different sources, cameras, network connections, files, and you can encode them and decode them as you wish. You can transform them, you can apply effects to them, and then you can output that information. Again, you can sort of encode it, say, as we're doing in H.264 or equivalents, and then you can output that in different container formats, such as MPEG or OGG, and we're using, for reasons that will become apparent a bit later on, we're using RTMP streams. So effectively, on each of these devices around the room, we've got an embedded Linux running, and on top of that, we've got GStreamer taking camera input and running this pipeline and encoding it in hardware, because luckily these things support hardware encoding, which is nice, encoding it to H.264, wrapping that in an RTMP container format, and pushing that out as a stream. Now, we can push that straight out onto the internet and connect that to wherever, YouTube, Twitch. One of the things that Matt, in fact, was showing me the other week, which we can look at in a sec, is this cloud platform called Restream.io, which we're using, which allows us to stream this RTMP stream out to one place, and then it will stream it on elsewhere. So Twitch, YouTube, Facebook, and there are lots of other endpoints that you can use. So, we have options as well of sort of changing the pipeline around, and instead of RTMP, we can use these other formats, we can use MPEG and so on and so forth, but we are where we are for now. Now, so the next thing is that Matt has been doing great work with his server internally on the local network, which is running a set of VMs, and what we're doing at the moment is streaming these streams from all these cameras to his box, where each of those are coming in as an individual stream, of course, and it's going into a tool called OBS Studio, which we're talking about, and hopefully we'll demo to us later, where you can mix all these things together and you can flip between different cameras. And if you have a guy, girl, and you're working from a laptop with your event, you can move the camera sources around really, really easily. So it's kind of basic CCTV stuff, obviously, that you can see here. But with a little bit more effort, you can actually do something a bit cleverer by flipping between these different cameras and audio sources too.
And nice like transitions and stuff as well. And you can do stuff like Matt did for the event downstairs, where you have like a holding screen. So say the source goes off or whatever, you just go back to a nice rolling holding screen, or you can put in pre-recorded footage. It's really good. You can mix like a proper TV channel with it.
And open as well. And
it's open source, yeah. It's fully open source and cross-platform. It works on Mac, Windows, Linux. I don't know about BSD, I'll be honest. It works on BSD. There you go. It's available for free. If you're on Linux, most distributions you can just like get it, or go into your software manager and look for OBS Studio.
Yeah, I set Julian's up in like a matter of 5 seconds because it is just so simple. It's just one tiny command.
So the weird thing about it is it was called OBS, Open Broadcast Studio, and then when it first came out, and then they rebranded it OBS Studio, which I find odd because that's Open Broadcast Studio, but never mind to say. So if you look for OBS Project or OBS Studio, you'll find it, and you can just download it off the website if you want.
So before I talk about resin in a little bit, before I do that, I mentioned Restream. So let's have a look at that. It's probably horribly wrong. Let's see if I can full screen this one.
The resolution's low on that.
My God, yeah,
That's not bad.
so this is, as you can see, we've got our image again in the top right here. So this is the cloud platform. Matt's box is taking all of the individual streams on site, muxing them together into another stream, and pushing that up to where you can see in the right-hand side RTMP URL. So that's the endpoint that we're using for this Restream.io account. Restream is showing us that we've been live for nearly half an hour, resolutions, frames per second, bit rate, that type of thing. And then what it does for us, we can add multiple channels from the supported sources, and the max is about 30, yeah? Mm-hmm. And we're now restreaming live to DoESLiverpool on Twitch, DoESLiverpool live on YouTube, and the DoESLiverpool Facebook page, which is kind of nice. And you can connect this into sort of social notifications that will say so-and-so's gone live, and etc. Now, it is a paid service. You get a free account with I think Twitch, YouTube, and some other features. The Facebook is a paid feature, but it just makes life quite easy. It's quite an interesting thing for us to explore. We've been using that quite a bit with our experiments in the past week or so.
It also lets you know when you've been banned as well, because if anyone in the room wants to play music, Facebook will immediately pick up on that and just end the stream.
Yes, as we found.
Yeah, there's an algorithm that looks for. Actually, I don't want to drag it too far off topic, but I've used like Creative Commons music, which is perfectly legal to use, and their algorithms picked it up and banned me, only for a short amount of time. But actually, it's just because their algorithm, I just think, defaults to like banning everyone, which is actually wrong. But what you do? Well, kind of, but if it's a song that sounds a bit too much like another song that it knows, then it'll ban you.
So someone's made a remix of a nice tune and they put it.
Well, that would be illegal. A remix.
But they've released it on the Creative Commons, and you think it's Creative Commons, so it picks up on.
Well, true. Yeah, true. But it is live now, so on my phone I can just go to DoESLiverpool and YouTube, and I could be walking around town on 4G and go. It's quite cool. And the good thing about YouTube, apart from the business with the copyright thing, is that it's on every device, it's on every phone, it's on every TV nowadays. Anyone can just pick up your YouTube stream, whatever you want.
So, another component, another piece of the jigsaw that's out there is a service called Resin.io. Again, it's a commercial entity, it's a commercial service, but it comes out of open source work that these guys have done with an embedded Linux project called the Yocto project, which was set up and is backed by the Linux Foundation. Without sort of going on a great length, Yocto comes out of work called Open Embedded, which comes out of work called OpenWRT, which comes out of people who wanted to hack their Linksys routers back in the day, and it's all kind of stemmed from that. So it's an open build tool chain for creating your own embedded Linux distributions, which I use in my work quite a lot. And through that work I came into contact with the guys who developed some of the software for Resin.io, and what they've been trying to do is to put together a cloud platform to make it really, really easy to push down your software and your firmware and your updates to embedded devices that you've got in the field. So if you've got 10 or 100 or 10,000 devices all around the place, as long as they're network connected in some way, you can develop your software and test it, push it into a Git repository, and boom, it will be compiled up and tested and downloaded to your set of devices. So you have a continuous delivery mechanism. For our purposes, Resin's quite nice because it allows you to set up a free account with up to 10 devices to play with. If you're doing things that need more devices, then you have to be paying for that. For us, it's fine. And the benefit of this is that you can download the sort of equivalent to Raspbian, their embedded Linux image, load onto an SD card, and put it in one of your devices, which will then connect up to the Resin services magically, provision itself as a new device, which I'll show you in a second, and start downloading whatever particular application you need to run on it. So we've got two different applications that we're interested in here. One is called Video Streamer, one is called Video Streamer 0, because we've got to separate out Pi 2 and Pi 3 platforms from Pi 0 platforms because of the different architectures. And on our Video Streamer application, we've got a number of devices, a bit difficult to see on the plate, but we've got up at the top there Pi 6, White Violet, Pi 4, Pi 3, and another one that's offline. And you can see from what it's telling us that the 3 Raspberry Pi 3 devices that we have online, so this guy, and the one Julian's playing with by the coffee machine, have been online for about 2 hours, and some interesting bits and pieces of information about those devices. For any one of them, should we wish to go and have a look at it, as I've been doing, trying to get them working early on, I can find my mouse pointer, and you can drill down into the device, and it's telling us that it's online, it's active versions of things that it's running, it's showing us a log of the latest and greatest things that have been happening. I can share this a little bit later if you like. Essentially, that's the GStreamer pipeline that we're running that's generating the video out of the Raspberry Pi. There's a PyCam source. We're doing some encoding to H.264, packing that into an FLV file, and then we're sending that to an RTMP sync on an IP address, which is the IP address of Matt's box. And then the uniqueness of it is that in that IP URL we see Pi 6, it's Pi 6 stream that we're showing. So it's quite nice to be able to see what's going on. And then if we want to get into it, the way that Resin works is that it keeps an open VPN channel from each of the devices out to the cloud servers. So I can go into the device, and I can see what's going on, and I can stop things, and I can start things, and I can fix any problems that come up, which is just a really nice thing to be able to do when you've got little black boxes all over the place, and you can't really see what's going on with them. And this allows us to go in and monitor and fix and update. As an example, if I can show you this, if I bring it up. Let's see, here we go. So I'm running a VM here, running Ubuntu, and I've got a set of code in here which is very basic. The innards of this are essentially the script that we run to stream our video, which is this one, and a file which tells Resin how to build up an image with all the dependencies we need, which is basically GStreamer. And I can put all of this in a Git repo, which I have done, and you can find that online on GitHub. MakeSpaceLive is the place to look at. So it's all open, it's all there. But we have other endpoints. You can see a Resin and a Resin 0 endpoint. And what will happen is if I push any updates that I make to this repository to the Resin service, Resin will take those, it will rebuild the image that it needs to send to any devices, and then it will push down whatever has changed to the devices. It's based on Docker, if any of you have used Docker. They've essentially taken Docker from a server environment and put it down into an embedded environment. So you have a base image, and then you have deltas which get downloaded on top of the base image with changes in. So it's very efficient in terms of the amount of bandwidth that you use when you're trying to push down to your embedded devices. And again, that makes it quite a nice, easy way to do your work, test your outputs, and then provision those down to sets of devices that you want to update. Any questions on Resin at all?
I've got one, kind of.
Okay.
As much as I love it and it is great and I can see the real use for it, is it open source?
Well, that's a very interesting question.
That's a no.
The embedded end of it is open source.
Okay.
If you go to, if you know about the Yocto project, if you go search for the Yocto project, you'll find it is structured in lots of different layers. there's the core part of the project, and then there are layers that pull in new functionalities that you might want in your Linux builds, like Qt 5 or Mono and this and that. Yeah, there's lots of them. And there are layers that pull in board support packages for particular pieces of hardware. Now, all the work on the embedded end that Resin.io have done is open and is available to you in the layers there. What is not currently open is the cloud end, the web interface, and everything that's going on behind that. Now, they have stated as recently as a couple of months ago that their aim is for probably a cut-down version of what their commercial product does to all be open. But it's, you know, if that comes along, that's great.
It is really useful. I don't want to say like I'm being at all.
No, it's a good point.
Yeah, well, the other thing is, as we said, we want the whole thing to be open and replicable and all that. As Julian pointed out, as Julian pointed out earlier, what we could, and for this, because we're deploying to a lot of devices, we want to be able to automate over the air and all that stuff. Oh, he is there. Sorry, Julian. I thought you'd gone out again. and as Julian was saying, we could just have an image that we DD onto a Pi. You know, we don't need that necessarily. If we just had local Pis, we could have these images ready. We've been working on them. Well, I say we, the Royal We, which is Alex, has been working on the images. So he needs to be able to update all the devices quickly. But once this is at a point where we're like, that's a solid image and that will do it, people could just download an image and flash it.
That's it. It's really
it's not needed essentially to get it working.
It's really important not to be hooked into
we're not
like that. And we're not. There is some documentation here on the GitHub repo to get it going. It talks a little bit about what we're trying to do, what we've looked at in terms of hardware and firmware. The enclosure designs themselves are all open source under Creative Commons on Thingiverse. You can grab them, you can print them on our Ultimaker, which is what we did. And you can look at what Matt's been doing, we'll talk about with LBS Studio and Nginx. And we'd love to hear a little bit more back from people about different webcams and the quality of the images and the audio that come out of those, because we haven't obviously tried a lot yet.
I'd like a list of approved devices, maybe, if people test them and approve them.
But coming back
to get this camera, it will work.
Coming back to support, talked a little bit about Resin. There are some instructions here how to get going with Resin. What you'll see, I have. But we don't want you to have to use that.
Yeah.
I mean, in fact, had some positive kind of feedback from the guys around us saying we don't want to do that. So there are instructions here for standalone where you can grab your Raspbian image, and it says here, grab the Raspbian image, set up your dependencies with apps, clone the MakeSpaceLive repo. If you're using PyCams, we have a custom GStreamer plugin which is open source that needs compiling. It's quite easy. And then you can run something like this, where you grab a URL and a key from somewhere like Restream.io or straight onto YouTube or Twitch or your own server. And those 4 lines, or 3 lines, 4 lines, will get you going live streaming. And then the kind of real magic part of it is getting the GStreamer pipelines right. And we have a couple of pages, it's early days again, but we're sort of building these things up. Some more notes here on how to set up Raspberry Pis. But we're building up a little list of various different kinds of GStreamer pipelines that you can use to play with. And that goes for very, very simple video test sources and encoding those for local display, through to encoding to H.264, RTMP streams, and we'll put something up there on MPEG streams as well, maybe AUG streams. Audio, video, webcams, some of the really exciting stuff that we want to get into. There's a bit of a question over whether Raspberry Pis are going to have enough oomph for this, but they do have a GPU on them, even the zeros, amazingly. And we can do hardware accelerated encoding and decoding and effects on the images that we're capturing. And some of the things that are quite interesting for the future are we can put other kinds of lenses on the front of these devices. So fisheye lenses for wider field of vision, 160 degrees, 180 degrees. And if we can then take that image in, it looks like the circular thing you've seen on the bulge. And if we can take that in, and in hardware transform that into a flat image, then we start to have a really wide field of vision. And we can maybe start looking at having a couple of those and pushing 360-degree videos out to YouTube. So we can have a really immersive experience for somebody to come along with Google Cardboard or one of these other headset devices and actually feel a little bit more as though they're in the room looking at you. Now,
for the millions of virtual attendees.
And, you know, it might not be possible with a Raspberry Pi, but again, this is a kind of an exploratory thing, and all of this being open can very easily be moved onto another embedded device that can run embedded Linux. So there's potential there too. Okay. I think that's me. Is there anything else I need to talk about?
No. What was that, sorry?
I missed the demo.
No, we're going to go back to that. So we started with that, and then Alex moved into. Here we go. Oh, hang on. Too many windows open. So some of the other stuff which I've been doing, apart from sitting around and not looking pretty, is sorting out. We talked about. So Alex has hopefully registered MakeSpaceLive. That's the name, which apparently nobody had, which is interesting. So I've been setting that up with Django. Most people might be familiar with Django, but if anyone's not, it's a Python web framework, essentially. So what I want to do with that, long term, and this is all just kind of big picture stuff, is what we want people to be able to do is maybe use it as a community space where people can share videos, we could link up different MakeSpaces, events, whatever, through that, where they go on and create an account and hopefully eventually get something like DoESLiverpool or whatever their username is. And then that wouldn't be too hard to do. And then get it so that it's a whole kind of, and even the website, in my opinion, and I think in our opinion, will be completely open under AGPL v3 probably, or something like that. Obviously with passwords and security stuff removed. But so that people could host their own instance if they want. Again, the idea is that we're just putting this out there for people to run with and probably do very interesting things, more interesting than I'll do with them. But eventually that's the idea. So if people have ideas for things they want to see in it, or they want to contribute, or they want to say, I've tried this camera and it works really well, or it doesn't work, or all that sort of stuff, we want to build a bit of a community around it. And Alex has already done some amazing work with all the documentation you can see. So as it's only been like 10 days, yesterday I spent most of the day getting together all the infrastructure for the web stuff. And then maybe tomorrow I'll finish coding it. But I'm actually using, so getting onto the web stuff a little bit, I started using something called Wagtail, which is CMS, a content management system, built with Django, and I've hacked that into, I say hacked, it's a bit more pretty than that, but I've hacked that into the main project, and then we can start building on top of it. And basically, because it's all Python underneath, we can start doing some interesting stuff with it. But we'll have like an already pre-built content management system where you go on, you create your own account, and then you get a profile page where you can post your videos and you can go live and all that sort of stuff. For the question at the moment is things like hosting. So obviously I'm not going to be hosting all the video and contributing to the bandwidth on my server and the space and all that. But that's one of the joys of, again, although YouTube is not open source, we can leverage their fact that they record everything and put that back in so people can replay the videos later, they can deal with the hosting, and then if they change, we can move to another platform or whatever. So it's the idea. So I just feel like I've done something, to be honest. So there's that. And then I think if Matt's alright with it, would you mind talking a bit about OBS and what it is?
Yeah, you should plug in and actually show it.
Yeah, that'd be awesome, yeah. So, because this is the server end, obviously, so when it comes to kind of mixing the videos together, that's like Matt's department.
It is really basic stuff. I do think anyone could do it as well. Just because OBS is just so basic at this point that anyone can download it and sort of think, oh, I don't have HDMI.
You don't have just take off the HDMI though. And it makes it screwed in.
There's pliers too.
Pliers?
No. So it feels like.
Yeah, we glued that on.
Right, so what should I talk about then?
If you just show us OBS and then we'll show our people how.
See the streaming is what you're doing with VM there as well.
Oh, no, come on.
Yeah.
I can here as well.
What side?
Are you going to stream like here?
Oh, it's already.
Yeah, we can do that as well. We can stream it as well. But we can put that back on as well.
Does that work?
Yeah, that's good.
On the right or the left? Yeah, it's on the left. quickly then. So, OBS. Amazing piece.
That's a bit.
So this has been in development since around 2014, I think. And I've been using it ever since it started.
Yeah.
Because this is one of the first things that people use to start really streaming on platforms like, what was it, Ustream, LiveStream there. And you used to have to pay for those services to get the bandwidth to do it, but of course, now with YouTube offering that for free, no one else can charge for it. And I think some people still do it. I can't imagine how they make money. Anyway, we can add one of the inputs from over there that's already streaming. All we have to do is add it as a media source and give it a URL. So it's not a local file. The input is rtmp, //10.0.31.212, which is the rtmp server, which all of this stuff's going to. So all these Pis need to do is communicate, yes, rtmp server, I'm going there, and just push data through it, encoded or not. And it will deal with it and encode it if I want it to, but it won't, the rtmp server doesn't have to do any work. It can just push content around as much as it wants. So Pi 1. In about 4 seconds that should show up.
Yeah, we need to look at where all that latency is coming from.
Yeah, so
Because it goes via China. That's a joke.
that doesn't work, does it?
Well, it's live demos never work.
Yeah. So I did have this working before. Maybe you can
Yeah.
I might connect this to the network here. And I'm getting a very recent.
There you go.
There we go.
So that's the one that is. Where's that? Is that the one?
That's Pi 2.
Where's that? It's behind. Yeah, it's behind you. But okay, so that's that one. You'll be at the beer. Yeah, there you go. So there's a bit of latency, obviously. There you go.
So add another one. Have you got your laptop, Julius? Is it still streaming right now?
Should be.
Right. So I had Julian going earlier to the RTMP server. No one do this, by the way. Stop it! Yeah, let's hope. Oh, that's the hypervisor. So that's actually running in a VM. So we can actually take a look at this now.
Yeah, that's just the Debian VM I talked about, isn't it? This is where I tell you your password.
Oh, wait, no, I always lose track. So this is the virtual machine inside the hypervisor, which I'll show you in a moment. Right, there we go. So this isn't running anything particularly intensive at the moment. But earlier what I was trying to do was set it up so that it would go to YouTube with multiple cameras, because YouTube has a function, a nice function where you can take, say, 6 RTMP streams, push them, and then you can give a link to someone and they can click on the taskbar and go to any camera that they want.
Yeah,
so we could have all 6 cameras in here and they could just say Pi 1, Pi 2, Pi 3. Alternatively, laser room, laser printer 1, laser cutter 1, etc., etc. And that was kind of hard to get working because YouTube doesn't actually want to do all of the CPU transcoding, believe it or not. So we have to give it to them in a specific curated way, like maybe with keyframe interval of 30 or something like that, which we failed to do in time. But I was really rapidly trying to get it done. In the process, all 16 cores were being used because it was trying to transcode that MPEG. So we do that in Nginx, which you compile, didn't you, Dan?
Yeah, I'll put up proper instructions for that. But basically, there's a good tutorial on that which I'll post. But it was just, it didn't take that long once Alex Selford pointed out to me that I failed to view the screen.
So essentially, all you have to do is start up an RTMP server and whatever port you want. This is the default port, so everything will talk to without any configuration. And you can choose whether these are live on the network. So if I turned off Pi 2 here and then reloaded the service, it would die. And that's really how simple the configuration is. And then you can add things to that, like, I don't know, execute GST launch, and encode it with whatever you want, and then do whatever you want with GStreamer or MPEG, etc. to that video stream. Like, once it's on Nginx, it's in your domain, you can do whatever you want with it and push and pull it wherever you want. So I noticed that I had this free since I set it up differently this time, and so I got Julian to stream to it. So now I can go to RTMP on this server, Right? It should come up with his laptop if he's still streaming, which I don't think he is because. Yeah, I think he stopped streaming at a point in time. Yeah.
It says start.
Start streaming.
Just, there you go.
So now we've got Julian's laptop screen in OBS because he's streaming through OBS, his screen rendering it with Tempe or encoding
This
it.
name keeping its own tail.
Yeah.
There we go.
Right, so it really is that easy. And if there was a dashboard of some sort to sort of help people out with starting and stopping RTMP stuff, like maybe you could run an RTMP server on your phone.
Yeah.
And then create an application that just says, okay, these are the RTMP streams that are showing up on your network. Would you like to connect to it, vice versa? And then you can push and pull video around really easily without having to do anything on the command line.
We talked about building a web interface, and obviously that would be easy.
Yeah.
It shouldn't be that hard actually, but maybe as part of the web stuff that we're doing, building a web interface that we use for starting and stopping the cameras.
So that's really all I've been doing, is just sort of setting up the RTMP server, making sure everything runs relatively smoothly. Yeah, that's all I've
For a
done.
moment, I could explain what I got.
Yeah.
Oh yeah, sure. There'll be a bit of latency though.
Yeah, well.
There you go.
So this is the old coffee bot from early days of DoES, which you can see it there.
There you go.
Early days of DoES where perhaps you put an electronic scale and amplifier and wheatstone bridge and so forth, and try to put the weight of the coffee machine onto the internet so you know how much coffee goes around. So nowadays, let's see if we can go find this in the using this new high-count stuff. We can do it all in the same way a human would do it, which is using their eyes. It's all this complicated stuff. What we do is we set up a machine.
What if somebody cleans the coffee mug and
Oh, there's always someone.
the words
the same one as well?
Somebody siphons off the coffee while simultaneously pouring in plain water.
But it's more that a lot of these sensor things that people do, like proximity sensors and stuff for trying to capture other people, can just be done visually. This was a frame grabbed from the live stream. So this is using what do we call it? It's OpenCV.
OpenCV.
And you can just pull out a frame like this, and then trim out to a section, and so in a moment, which you'll see. To make it easy for the computer, you stick a little yellow thing behind it, which is going to be obscured by the coffee. And trying to do general computer vision is very difficult, but you can help.
It's a very dark image.
And so after doing that, we can do
That's the whole thing.
a particular shade of the yellow, which comes up like so in a moment. There we go. Now we've got that. Yeah, there we go. There's a shade of yellow. And then
This is awesome.
That's the best thing
by then doing some eroding and trimming away individual bits, there's min area rectangle, which can get a little red rectangle, which is kind of like a gauge height. This is just pulling it out together.
Yeah.
And then what I then did is put the output into MQTT as cotton dot level, which will be showing up in a moment at the top. Okay, and then following that, everyone's been playing with node red. So there it is, hold this coffee vault level, and it goes to node red as coffee vault level, and this goes to a level of the gauge, which has been outputting recently into this page here, which will come up on the UI. So someone needs to go pour some coffee out and see if it actually works.
Alex, too sugar then.
I'm guessing the reason that it's so spiky is that these lights are really horrible and they flatter.
So you rely on the level of light around the coffee.
In the same way as your eyes would. I mean, you know.
No, I also think about that. I was thinking of all the method of having a sensor which would be light on in that sense.
Yeah, but no human goes and measures the level of coffee by sticking their finger in it or weighing it. In the visual sense, it's really powerful.
There you go. So Alex has taken some out, I think.
It caused a spike because I guess when he took it away, the entire yellow strip was visible.
Yeah, of course. Yeah.
And so now
he's put it back, which should be.
And it's gone higher because it's the level of the yellow strip.
Right.
So it's gone up from 100 to 140.
Very variable.
It's variable because of the splash.
No, the flashing, sorry. Right. Also, it might be sloshing around a bit.
It's not slosh.
It's not. You haven't seen it. Have you seen it?
Anyway, so that's the power of it and trying to use visual things. Whether we can convert, whether we can now this OpenCV script can actually run on the Raspberry Pi once you get it working, and so that it can just put out the level and doesn't need to go through all the visual stuff.
But you did all this in like 2 hours today.
Yeah,
it's amazing.
So it's because I know the trick of sticking coloured things behind things.
Yeah.
Anyway,
So with a different coloured bar then, or?
probably.
Does the flickering of the
I just
camera?
happened to find a yellow thing from the scrap heap. So to be fair, I was doing this earlier. If we can get one moment, I'll just find the. Protection. I've done this code on this thing here. Should be appearing. Yeah, so it was originally doing it on Glider using a Pi camera, and I originally tried to measure the position of the pilot using computer vision, but then found things were a lot easier if I put a sky blue circle on there to the depth, but that makes things easier. So yeah, usually computer vision is to help it out, is the trick. Anyway, so that's what I could do in 2 hours because I've done it before.
That's awesome.
Fantastic.
Yeah.
And the really cool thing for me is that, and obviously you're in the same room, but you're streaming via the ITMP, so you could technically be at home or something. You had a microphone and stuff we could be listening to and watching you.
Unless you can improve the latency of it.
Yeah, it would, it's true.
But apart from that, it's.
What's causing the latency issue?
Just the protocol itself. Yeah. The protocol RTMP is just not designed for low latency, which is why we're trying to get to it with WebRTC, which is more recent, which is really low latency.
So the latency problem locally, it's not due to the.
No, it's to do with the protocol
You
itself.
can't adjust the buffer on RTMP, are you sure?
Maybe it can on.
Seconds,
I think you should.
Is it 16 seconds? It's more like 4 or 5, isn't it?
It's not
16.
Wow, that's pretty bad, yeah.
16 seconds?
There must be
Some of these devices are on Wi-Fi as well, which might also contribute.
Not that much.
0.0 microseconds.
Yeah.
What you don't realise is that time moves slower in the other room. There's a temporal vortex just by the toilets, which we don't know.
But it is on 50 hertz range, so I think a lot of the equipment will work, if not all, it will go away to switch to cameras to 25 frames.
25, maybe. We could try, we certainly try that.
Does that have to be done on the cameras, or can you do that sort of in the post-processing as well?
No, the capture time. We're capturing staggered from the rings, so.
It would be better to get better lights.
It would be much easier to just rather than have to reconfigure every camera.
Yes.
So you will have where you deploy cameras across all the country, you have 50 hertz and the right to light and but everybody will.
Add it to the web interface like a sort of offset option, something like that. So,
Maybe, yeah, you could offset it. So if anybody's got any suggestions or you want to help out, then have a look on. I'll post on the mailing list and in other places, on Twitter and stuff, all the links to Alex's stuff. But if you go to MakeSpace.live at the moment, there's a very ugly text message basically on the page which says, gives you a link to the GitHub repo and everything else. And just because I used the username MakeLive everywhere, I came up with the slogan MakeLive, not war. So that's the kind of
Lovely website.
MakeSpace.live. There you go. That's it.
This one.
Yeah, go down to the bottom.
There will be a better website
Right
for
down
that.
to the bottom there. So there's a set of environment variables, the basic set of stuff here. What you can do is, before you run the script, if you set the video frame rate, you can override the frame rate what you want if you fancy playing with that. What you find is that there are a limited set of combinations of frame rate and video image that the input sources can provide. Webcams seem particularly sensitive. But you should be able to put 25 in and really start doing that. No, we can try that.
So we're certainly trying that. That's really good to know.
So is this configuration, what are these variables for?
Just to override the defaults.
Is this handled by the kernel, or like the kernel, is this the way it handles video? And
So the way it's running is Python script, which has some defaults, and it checks these environment variables and uses those in
so it's just arbitrary, it's not like...
Yeah, it's just like an opta. It then builds this pipeline using these numbers, so we can change sizes, resolutions, and frame rates. And the idea is in future to have some kind of back channel through to devices so that we can do it in real time and change bit rates and qualities and those kinds of things.
I wonder if there would be any way for the software on the device on the Pis to actually query the camera and then to adjust parameters so you give it some like a minimum maximum resolution. Because I know from experience now with the bus that some webcams have different combinations and resolutions. So if you give it a fixed resolution, you run the risk that some cameras just don't want to work and you have to keep on trying.
So you find the right
But
one.
if you have some smarts on the device itself to give some boundaries, and then you would probe the camera and then just find a combination that works, and then it would sort of be less messing and a bit more flexible to work with various cameras.
With the script that we've got, it's really, really basic. And absolutely, one of the next things that we probably should do is you can inspect the sources. So we use a LivLUG source for webcams, and we use this kind of custom iCam source for iCams. And you can inspect those sources and ask about their capabilities. So absolutely, we could and should add to the code to say what's the best thing we can do. How does that fit the needed bit rate and what we need to output to the endpoint in terms of frame rates and sizes, and we'll work out what the best thing to do would be. That would be fantastic.
With OBS, can you integrate with a PTZ? So you add to the zoom of a camera together?
I mean, OBS actually has a Python plugin, so there's no reason you can make your own sort of thing for that, but natively now, there's no sort of universal support.
It'd be nice
Yeah.
to have sort of a tracking shot you could do.
So something I forgot.
Just something to fancy.
Yeah, something I forgot to bring with me again. I keep forgetting is I bought off Amazon from a generic Chinese kind of network camera, IP camera that does pan-tilt zoom, and it does. I forget which one. It doesn't do RTMP. Maybe it does. Anyway, long story short, I got it into OBS when I was playing with it at home. And what I was able to do was use the app on my phone as a remote control and watch it in OBS and go pan left. And as I did that, it would change and zoom. But it's £35 and an app on the phone.
Isn't there an open protocol control PTZ?
Yes.
Probably, it probably is. Yeah, it surely probably is. It's just I just got the camera to play around with, so I'll bring that in.
The camera has to actually support it.
Yeah, there we go. There we go.
Yeah, PTZ.
So someone's already made a plugin for PTZs.
It depends which PTZ protocol it supports.
So one of the good things about OBS is the community is massive. It's really popular, mainly because people like to use it for streaming games with. Massive in the gaming community. It's become the default for everyone playing Fortnite, whatever else they play, I don't know, to stream what they're doing. OBS is huge for that.
That says something about VSCO commands.
Yeah, there's something.
What was that, sorry?
There's a
Open-
comment, there's something about VSCO commands.
Spell that out.
It's there.
Visca.
Visca, is that the
That's,
protocol?
no, that's new to me. I was thinking it was a non-protocol.
Yeah. That's obviously a Windows one because it's talking about DLL.
Yeah, it's supported on Windows. And that's actually kind of a problem with OBS. The problem with OBS is because it's broken, because it was so supported natively on Windows, and Linux support kind of came later. A lot of stuff, sort of stuff with DLLs.
That's what we got wine for, isn't it?
A lot of this does work with wine.
That's where you use wine or something.
You wouldn't believe what works with wine.
No, it won't work with wine, I wouldn't think. But
You wouldn't believe it. A lot of these plugins people do just resort to using wine with specific setups. So you, like, there's one way you can adjust things on stream, like sort of like Photoshop effects on stream.
The important thing is, if there are protocols available, then we can re-implement it in a way that
I mean, there's some
available on any platform.
There's some plugins that only support Windows on the pre-compiled version, and then they say go and compile it yourself.
Compile it yourself, yeah. I've seen quite a few of them where, unfortunately, you get back. I mean, it's like the old days of you go and look at a piece of software and it goes, the Windows version, here's the exe, here's a tarball with the source, and go and find the dependencies. If you want to put it on another platform, which is, possible for us.
You've got a Python interface and a Lua interface, so you can do a lot with that.
Yeah, you can do quite a lot with it. So feel free to ask any questions. But I thought, I don't know what you guys think most. I thought maybe we should let people have a look at the cameras themselves.
Absolutely. Yeah. Can you use a network camera? The camera you just mentioned?
Yeah, it's an IP camera.
Does that output RTMP?
Yes, it does. I'll find the model and stuff.
Most of them now,
It's got about RTMP.
It does MJPEG.
You could make it. So most IP cameras output MJPEG, like you were saying.
And it does.
Which you don't even need that. I think you can just straight up grab the frames with GStreamer on.
You can actually grab the output straight into
so there's an application called IP Webcam on Android which you can grab and it'll do the same thing. And it'll just output to a URL.
Yeah. So you have to output that MJPEG and then on your server you have to...
Well, I use
GStreamer.
Mine's with H.264 straight. It's quite good actually. I was just bought it because it was cheap and I thought I'll have a play around with it, and actually it's not better than I thought it would be. It's I'll post the model and stuff. I presume it's still available, but it had all the pan tilt zoom stuff, but it's got a massive wireless antenna on it and an Ethernet port on the back, so you can either fly it straight in.
You know that GStreamer command box?
The one
that grabbed the MJPEG frame.
that I was thinking of is actually OnViv.
OnViv.
OnViv is actually industry-wide body that was charged with developing protocols for CCTV cameras, including for interoperability and PTZ.
Yeah.
And various manufacturers adhere to some extent or not.
Sweet. Cool. So feel free to have a walk around and have a look at stuff. As I said, if you want to help out and contribute, with whatever even just a bit of research and saying I've tried this camera and it works or whatever, then you can probably do that by GitHub and when you want to see those things. Alright, cool. Thanks everyone. So have a look and see what Alex can probably say a bit more about the hardware. Basically these are, can I pick that up with my phone on tape it? So this is the one, this is my one from earlier, wasn't it? You put in your enclosure. I'm going to unplug it unfortunately because the only way you're really going to be able to pass it. So this is the resin one, isn't it? And don't get confused with resin IO. This is just a Pi 0. Sorry, I just snapped the bit off. But it wasn't an important bit. And then you can pass it around. But inside you'll see Alex has fitted it in with a bit of blue tack or white tack or whatever. But it's just a Pi 0 and a Pi 0 camera. So the Pi 0 is £6 or £7 I got it for. And the camera's the most expensive bit. The camera was £15. So together, what's that, like £21, £22? Still pretty good though. So I've already broken it, so please don't break it. Well, it's a bad design, but maybe you shouldn't let me touch it. So probably more platforms, isn't it? Well, actually making it more user-friendly. The other thing which you didn't talk about was you did something in where you could set SSID and stuff via a phone app on a local. Was that right?
Yeah. I mean, again, sort of getting into a bit of a conversation about provisioning.
Yeah.
It's difficult, isn't it? If you've got a little black box device and you're using Wi-Fi, you're putting it into a new environment, you've got to get it connected up somehow.
Yeah.
There are lots of different strategies to try and deal with that, but we've leveraged a project that comes out of these resin people, which is kind of a separate thing, it's open source. Interestingly, Adrian McEwen's used this as well for his GoLab project that he's working on. But basically, you bring up the system, the Raspberry Pi or whatever, it tries to connect to whatever it's configured, one or more Wi-Fi access points. And if it can't connect to that, it falls back and it sets up its own access point. So you can then connect to that access point from your mobile device, your phone, and it will pop up with a web page and it will allow you to configure. The most basic implementation is just it will also detect any access points SSIDs around. You choose one, put in the password, and then it will cycle around and connect to that. You've got connectivity. So that's quite an easy way of onboarding things in an environment.
We don't want to do stuff that's same chain.
That's actually the sort of firmware of the soft devices, isn't it?
Or a Chromecast.
It's that kind of idea. Yeah, absolutely.
It's something like a
It tries to
Chromecast.
connect, if you can't connect, it goes into OP mode.
That's what most people are doing.
And the other thing I forgot to mention is, in the interest of making things easy, the reason I put stuff onto KVM is that we can, once it's ready, distribute that as an appliance to people. So if you don't want to have to learn how to compile the Nginx server and do all the rest of it, we could, in theory, say, there's the VM.
There's an extra wrinkle with this, where you basically also print a QR code, there's no access point.
Yeah, that's true.
So you just
QR codes, Jackie. See, I love QR codes.
Alex loves QR codes.
There we go. So,
Oh yeah, so you've done your phone.
yeah, kind
You
of.
could even do it as Docker each, couldn't you?
We could do it Docker, yeah.
Wouldn't even need to run VM.
No, not necessarily. Because it really is just Nginx. The hardest bit of setting the server up was actually compiling the stuff into Nginx and getting that working. And that might be.
You need to component.
Yeah, you have to compile in the RTMP module, which is a third-party thing, and then you have to compile some. You have to have quite a few dependencies.
So you have to recompile Nginx to use that module.
You recompile Nginx because the binary, packaged distributables on most distros they just don't have it.
It's a nice guide though.
But it's really, it's not, if I could do it, then most of you can do it, it's not a problem. At one point, as Alex helpfully pointed out, I think I might have been tired. I spent ages trying to do it and it kept complaining it wasn't doing it. I was doing like configure and make and all that. And then Alex walked in and well, it does say on there you're missing such and such a dependency, and I just installed the package. I think it was ZLib or LibZ or ZLib, I think it was. And I installed that, and then finally, funny enough, it compiled.
It's amazing how many bugs are solved with night sleep.
Well, just by reading the screen.
There's a lot of stuff by reading the instructions as well.
There is. Who does that? You have to go, and then when you can't do it, then you go back to the instructions. Yeah. Well, just to stop people from getting, put off by having to do all that, we can distribute that by Docker or maybe both Docker, KVM. I quite like those. Any of those things.
So you're streaming over the camera now, man?
Oh, wow, so stuff.
So is that nothing on there again? Yeah. So it's come a long way in 10 days. Alright. So who knows, in another 10 days we might have a working website and everything else.
That's my